All right, guys, welcome back. This is the second part of the 8.7 instructional video. In the first part, we explored what exponential functions were. We started off by looking at the penny problem. And really, the difference between an exponential function and a typical linear function is the linear function increases or decreases at a steady rate. We add $100,000 every day up to 30 days, so to speak. The exponential function doesn't increase by a steady amount, but rather multiplies by a steady amount. It doubles, it triples, it's cut into fourths, it's cut into halves. That, on the other hand, has a different growth than a linear growth. It's called exponential growth. So once we went through the penny problem, what we looked at then was the general form of all exponential functions. If something has exponential growth, what's its equation going to look like? And then we evaluated some exponential equations. And then finally, we created some exponential equations. And then we stopped there. And where we will pick up is graphing them. So how do we graph in exponential functions? Well, we've got 4 steps. So pause the video. Go ahead and write them down. So what do we do for graphing exponential functions? Well, to graph them, you treat them just like we did way back in 7th grade when you learned how to first graph a line. You're going to identify some x values. I would always encourage you to use the following: -2, -1, 0, 1, and 2. They're simple numbers, and they'll give you a good picture of your data. Number 2, you're going to plug x into your function. Okay? By function, I mean the exponential equation. Once we plug our x values into our exponential equation, we'll find our y value. Then we will plot our data on the graph. So let's see how that looks. Let's say I wanted to graph the exponential function y equals 2 times 1/2 to the x power. 2 times 1/2 to the x power. Well, first things first, I'm going to identify some x values. And as I mentioned before, I will almost always exclusively use the following: -2, -1, 0, 1, and 2. They just give me a great picture of my data. When you do these, I don't care what values you use, but I would like you to use at least 5. Okay, you can see I'm using 5 here. Please use at least 5. With step 2, well, step 2, we're going to plug our x values once we've chosen them into our exponential function. How's this going to work? Well, let me show you an example, then I want you to pause the video and do the rest. Plug your x value directly in for x and solve. So I'm going to plug -2 in for x. Again, this goes back to, how do I use my exponential function or my exponent rules? Well, I know when I have a fraction and a negative exponent, I can just flip the fraction and it'll make my negative exponent positive. From here, distribute that exponent and I get 2 times 2 squared over 1 squared. 2 squared is 4, 1 squared is just 1. And I'm left with 2 times 4, which gives me 8. Let's do it again. Plug in -1 for my x value. Again, I can flip my fraction. I know that anything to the first power is just itself, so really this is just 2 times 2, which gives me 4. Again, this is the exponent rules in action. This is why we learn them. Just to help you all out, let's do a positive value. One-half to the second, distribute that exponent. Get 1 squared over 2 squared. Should be 2 times 1 over 4, which simplifies to 1/2. Or you can write it as a decimal. Okay? I will let you pause the video right now and try and figure out what 0 and 1 as x values give you as y values. So pause the video. Give it a shot. Okay, you've plugged 0 and 1 in for x into your exponential function. And what you should end up getting is 2 and 1. Now, a couple things I want you to notice. Number one, our rate of change, our b value, which we learned about in the previous video, is 1/2. If our rate of change is 1/2, theoretically, my y values should be decreasing by 2, or they should be dividing by 2, which if you look, 8 times 1/2 would give you 4. 4 times 1/2 would give you 2. Your rate of change should be consistent down your y values. It's a great way to check your work. See if your rate of change is consistent. In our case, it is. So once you have found your y values, go ahead and plot these as ordered pairs on your graph. When I do this, to make my scale make sense, I'm going to go up by 2s on my y-axis. Maybe you did something a little bit different. And I'm going to plot my points. At -2, I'm at 8. At -1, I'm at 4. At 0, I'm at 2. 1, I'm at 1. And at 2, I'm at 0.5. And when I connect my line, it's not going to be a line. When you connect your dots, it's actually going to make some sort of curve that kind of looks like this. We'll talk about it a little later, but all exponential functions are going to be a curve of some sort of shape, somewhat like this. And this is how we graph exponential functions by hand. Just like you learned how with lines. Pick some x values. I would always recommend -2, -1, 0, 1, and 2. Then find your y values by plugging those x values into the exponential function. Plot your points as ordered pairs. And then finally connect it with your curve. Okay, let's try another example. But I want you to do this more on your own. I'm going to give you the exponential function. See if you can do the whole thing by yourself. Your exponential function is 3 times 2 to the x. See if you can figure it out on your own. Well, hopefully you've given a shot. Maybe you're stuck. Again, as I start to work through this, pause the video if you got stuck. Once you figure out what you need to do, pause that video. See if you can finish the rest of the problem. I'll just give you a couple examples here of me plugging in values for x. If I plug in -2 for x, we know that negative exponents turn into fractions. So I get 3 times 1 over 2 squared, which is the same thing as 3 times 1/4, which is 3/4. But as you saw before, while I find this as a fraction, I'm going to turn it into a decimal over here. It'll be a little easier to graph. On the other side of things, I maybe plugged in 1 for x. Again, you should be doing it for all these values. I'm just giving you a couple examples. It's pretty simple. I get 3 times 2, which is 6. Okay, if you struggled with plugging in your values, go ahead and pause the video and give it a shot. To finish out our table, what you should end up with is the following. You should end up with 0.75 for -2. -1 should be 1.5, 0.3, 1.6, and 2.12. Again, check that rate of change. I should be doubling. 0.75 times 2 is in fact 1.5. Times 2, you get 3. Times 2, you get 6. So since our rate of change works, we know we're good to go for graphing. On my x-axis, again, I'm going to go over by ones. My y-axis, I think I'll go up by threes. You could have chosen something a little different. At -2, I'm at 0.75, so a pretty small value here. Pretty close to the x-axis. At -1, I get up to 1.5, not quite to 3, but about halfway there. At 0, I'm at 3 on the dot. At 1, I'm at 6. At 2, I am at 12. We connect them. We should get a curve looking something like this. Folks, pause the video right now and put a little star in your notes. If you are unsure of a certain step I followed, whether it's how I picked my x out values, how I found my y values using the exponential function, how I plotted them, or how I graphed them with the curve, let me know. But this is how we graph exponential functions. Now the final piece to this, to help you all out, I've made a little key for you. And I do want you copying this down, because this is going to help you big time in the long run. Now there's a lot of parts to it, so let me help you out by talking you through it. Here is my big chart. Rules for graphing exponentials. Remember, all exponential functions have the form y equals a times b to the x. And if you want to just go ahead and copy that on the chart, pause the video, copy it down, and then just listen to the explanation, I think that's a great idea. So rules for graphing exponentials. Well, they're all in the form y equals a times b to the x. But dependent on what the a value is, or what the b value is, will depend on what ends up happening with our graph. What you can see here is I've drawn some general pictures. So what are we looking at here? Well, what you should notice is the a and the b influence different things. You see, what the a value will influence is what side of the x-axis the curve is on. If your a value is positive, your exponential function curve will always be above the x-axis. See how it's above the x-axis? If your a value, your initial value, is positive, your exponential function will always be above the x-axis. If you think back to the exponential functions we just graphed, both our a values were positive. Consequently, both our curves were above the x-axis. What the b value will influence is that which end, the left end or the right end, will have the high point of the curve. What you can see here is if your b value is greater than 1, the high point of the curve, or the really, really low point, depending on if your a is positive or negative, will be on the right side of the graph. When you're shooting up or shooting down, it will be on the right side of your graph. That happens when b is greater than 1. This would be the second example we did. The first example we did had a b value less than 1. It was a fraction. What that causes it to do is the part of the graph where we either shoot up or down will be on the left side of the graph. It will be on the left side of the y-axis. The extremely high or extremely low values will be on the left side. Okay, and that's if your b value is less than 1, aka a fraction. Now, your graphs might look a little different than the curves I have drawn here. But the point of this chart is a check sheet. It's to help you figure out, did I graph it right? To check your work, look at the two exponential functions we just graphed. The second one we did was y equals 3 times 2 to the x. The first one we did was y equals 2 times 1/2 x. Look at the graphs and see if they match what the chart tells us they should. Our first one has a positive a value and a b value greater than 1. Those meet right here. And what do you know? Our graph looks like that. If we talk about our second one, It has, again, a positive A value, but this time B is less than 1. And consequently, our graph looks like that. Folks, this is a little cheat sheet. Whether you're matching graphs to functions or whether you're just trying to make sure the graph you did is correct, use this as a hint. If your B value is greater than 1, you are going to have the high point be on the right side or the low point be on the right side. If your B value is less than 1, the high or low point will be on the left side. A, on the other hand, influences what side of the x-axis we're on. We'll be on the positive side. If A is positive, we'll be on the negative side of the x-axis if A is negative. Guys, thanks for watching. As always, email me questions. At this point, you are good to attempt your 8.7 practice. Let me know how I can help. Thanks.